All right, let's get into it. Today, we're going to do a full hands-on walkthrough of how to assemble the hardware for a differential GPS base station. You know, if you've ever wondered how surveyors get that insane pinpoint precision, well, this is exactly where it all starts. Let's jump in.
So, first things first, why do we even need all this gear? I mean, you've got a GPS in your phone, right? But here's the thing. Your phone's GPS is only accurate to within a few meters. That's totally fine for finding the nearest pizza place, but for a professional survey, no way. That's like trying to do brain surgery with a sledgehammer. We need accuracy down to the centimeter, sometimes even the millimeter, and that, my friends, is why DGPS is such a game changer.
So how does this magic actually work? Well, the concept is actually pretty simple, but it's genius. You set up this stationary base station, the thing we're building today, over a point where you know the exact coordinates. This base station listens to the same satellite signals as your moving GPS unit, which we call the rover. But because the base station isn't moving, it can figure out all the little errors being caused by the atmosphere and other interference. Then it just broadcasts those corrections out to the rover. It's that constant correction that gets us from meter-level accuracy down to something truly precise. Okay, time to get our hands dirty. Part 1. Building a stable foundation. And I can't stress this enough. The tripod setup is the critical first step. Everything else relies on this. First up, you're going to want to position the tripod right over your known survey point. If you can, get it on solid rock. That's going to give you the best stability. Next, grab the leveling plate. You'll screw that on from the bottom, right into the tripod head. Crank it on there so it's nice and tight. And before you move on, do a quick check of all the leg clamps. Make sure every single one is locked down. Seriously, any wobble at this stage is just going to ruin your data later.
Okay, now we get into the precision stuff. Start by just moving the tripod legs around to get the bubble on the leveling plate mostly centered. You know, a rough level. Once you're in the ballpark, you'll use those 3 little screws on the plate to do the fine-tuning and get that bubble perfectly in the middle. The last check is absolutely key. You have to look through the eyepiece and make sure you are exactly over your survey point. Here's a little trick. Put your boot near the marker on the ground. You'll see it in the eyepiece, and it really helps you line things up perfectly.
All right, our foundation is solid and perfectly placed. So next up is part 2, connecting the comms gear. This is all about the radio and the battery that powers it. So first, grab that radio antenna bracket. And here's a super important tip. Look for a little latch on the clamp. Don't try to unscrew it, you'll just waste your time. Just pop the latch, clamp it onto one of the tripod legs, and lock it back down. Easy. Then, you'll screw the base of the radio antenna right onto that bracket. And to finish this step, grab the battery and attach it to a different leg. This helps keep everything balanced, which is always a good thing.
Almost there with the comms. Now you just take the full antenna, it's usually a long whip antenna, maybe in a couple pieces you screw together, and screw that onto the base you just mounted. And the very last step here, well, it's the easiest one. Just plug the radio's power cable into the battery. Done.
Okay, base is stable, radio's hooked up. Let's move on to part 3, raising the antenna mast. This is where we get the brains of the operation, the GPS receiver, into position. This is pretty straightforward. You'll take the extension pole and mount it right in the middle, on top of that leveling bracket. That's what gives us our height. Then you'll take the GPS antenna itself, you know, the dome-shaped thing, and carefully mount it right on top of that pole. And hey, let me just pause here for a second, because this is really, really important. When you're screwing that GPS antenna on, please be careful. Go slow. The threads on these things are super fine, and you do not want to cross-thread them. That's an expensive mistake to make. So just take an extra second and make sure it's going on straight. All right, we're at the final hardware connection. See that cable coming from your radio? You're just going to plug that right into the port on the GPS antenna. That's it. This is the connection that lets the GPS receiver talk to the radio so it can broadcast all those important correction signals. So, check it out. The whole thing is physically built. But wait, we are not done. We've come to part 4, the all-important final step. And I'm not kidding. This is the one measurement you absolutely cannot get wrong. If you mess this up, pretty much all your hard work has been for nothing. Okay, here it is. You need to take a tape measure and very carefully measure the vertical height from the survey marker on the ground all the way up to a specific little mark on the side of the GPS antenna. You have to get this number exactly right, down to the millimeter. Why? Because the software needs this exact height to calculate all of your elevations correctly. If you're off by even a centimeter here, all of your vertical data will be off by a centimeter. It's that critical. And hey, here's a little pro tip for you. Learn the hard way. The second you are done with that tape measure, put it away. Put it back in the case. It sounds so simple, right? But trust me, losing a tape measure out in the field is a huge pain. It's these little habits that make your day go a whole lot smoother.
Okay, to wrap up the physical setup, just do a quick tidy up of the area. Get all your paperwork, manuals, whatever, back into the big Pelican case. Put away any empty cases or extra bits and pieces. Close up the main case. A clean work site is a safe work site. It just looks more professional, too.
And there you have it. The base station is built, it's measured, and it's secure. All the hardware is in place. But that kind of leads to the next big question, right? With all the hardware ready to go, how do you actually bring this thing to life? How do you power it up, get the software running, and connect it to the rover? Well, that's where things get really interesting.